Hi friends, in this video we are going to solve this problem. So here, change the order of integration and evaluate this integral. So here, limit of my first integration 0 to 1 and limits of my second integrations are x square to 2 minus x. So here, just observe the question. Limit of my second integration in terms of x variable, so that correct order must be dy dx. But here in the question, they have given dx dy. So here first of all we have to write the correct order of your integration. So here first I will draw the region, after that I will write the correct order of my integration. So here I said in my last video, so here let's say this is 0 to a and the limits of your second integration is in terms of x variable. At that time first integrate with respect to y and then dx. If here 0 to a, let's say 0 to y, the limits of your second integral in terms of y variable, at that time first integrate with respect to x and then dy. But here in the question, the limits of my second integration x square to 2 minus x in terms of x variable, but here in the question they have wrongly given, so they have given dx dy. So we have to write the correct form of integration is 0 to 1 x square to 2 minus x xy, this is dy and dx. So here this is my first step in the change of order of integration. So change the order of integration and evaluate the integral. So here first I will draw the region, after that I will write this step. So here with the while drawing the region, so I will write the point of intersection. So here first draw the region, then identify the limit and then find the point of intersection. So here with the help of this region graph, I will find the point of intersection. So here tell me, so the limits of my second integration from x square to 2 minus x, that must be the value of y. So that is not again the value of x. So here I will take x square which is less than or equal to y which is less than or equal to 2 minus x. The value of y belongs to this closed interval x square to 2 minus x, and if this is the value of y, so that must be the value of x. Therefore 0 is less than or equal to x which is less than or equal to 1. Now here come to the first closed interval. So here this means x takes all the value from closed interval 0 to 1. So here at left end of this closed interval 0 to 1, so x must be 0, and at right end of this closed interval x must be equal to 1. So here I got the two lines x equal to 0 and x equal to 1. So here x equal to 0 means complete y axis. Along the y axis you will get x equal to 0 and x equal to 1 is the line which is parallel to y axis. Now tell me, so here now I want to solve this here this interval. So here at the left end of this closed interval x square to 2 minus x, so here y must be equal to x square, and at the right end y equal to 2 minus x. So here y equal to 2 minus x, I will write this as x plus y which is equal to 2. So here which is same as, let's say this is my line L. So here this means here I will write divide by 2 x by 2 plus y by 2 which is equal to 1. So here this is the line x plus y equal to 2. This line intersect at x axis at 2 and at y axis at 2. So here this line L, so let's say this is my line L, intersect this line L intersect at x axis at 2 and at y axis at 2. So here this is the line, this is the curve. So y equal to x square, let's say so you know the graph of y equal to x square, you know the x equal to 0 and you know the x equal to 1. So here I will plot the graph with the help of this four quantity, x equal to 0, x equal to 1, y equal to x square and this line. So let's say these are the four curves. So here now I want to find the region bounded by this all the curve. 0, x equal to 0, 1, y equal to x square and this line x by 2 plus y by 2 which is equal to 1. So here first I will draw my xy plane. So let's say this is my xy plane. Now here in the xy plane, let's say this is my x axis. Here let's say this is my y axis. Now x equal to 0. Here this is the x equal to 0 and x equal to 1. So here x equal to 0, I will consider this is the complete y axis as x equal to 0. And here let's say this is my x equal to 1. Let's say this is my x equal to 1. So for the sake of understanding, here I am drawing the line. This is x equal to 0. Here I am considering this is x equal to 0. So y axis itself I am considering x equal to 0. Now tell me y equal to x square. You know the graph of y equal to x square. So here let's say this is the graph of y equal to x square. Now here let's say this is the graph y. Here y equal to, let's say, x square. Now here I want line x. This is the line. I want to draw this line which intersect at x-axis at 2, at y-axis at 2. Let's say if this is the one, so here this is the 1. X equal to 1 means here this x equal to 1 line intersect at x-axis at 1, here 1, and here let's say this is my 2. Here I am taking the coordinate. Let's say this is my a coordinate here with coordinate, a point with coordinate 2, 0. And here in the same way, here I am taking, let's say this is 1 and here I am taking 2. So here let's say here I am taking the point B with coordinate 0, 2. So here now I want to draw this line with joining these 2 points A and B. So here this is my line here, x plus y equal to 2. So here this is my line, x plus y equal to 2. Let's say this is my line, x plus y equal to 2. Here my graph is wrong. Here so let's say this is x equal to 1. So here now x equal to 1, so x equal to 0, and so this is the line. Here this line is x plus y which is equal to 2. So here x plus y equal to 2 line is this one. So here this is my x plus y line passing through 2 points A and B. So here I have drawn the line which connect 2 points A and B with coordinate 0, 2 and 2, 0. This is the equation of line is x plus y which is equal to 2. Now I want to find the region. So where is the region? So here just observe one thing. The x belongs to closed interval 0 to 1. So 0 is less than or equal to x, which is less than or equal to 1. So here x allow from here. Let's say this is x equal to 1 line. So here at this point the coordinates are 1, 0. So now I want to find the coordinate at this point. So here I want to find the coordinate of this point. So here at this point x equal to 1. So here this line x plus y. So here x plus y equal to 2 and here y equal to x square. They are intersecting at each other. Here at this point, here this line, here at this point, this line x plus y equal to 2 and this y equal to x square, they are intersecting at each other. So I want to find the coordinates of this point. Here I will write, after that I will write the coordinates of this point. Here let's say this is the, where should I write? So this, I want to write the coordinate at this point. So here let's say this is the x, y equal to x, so sorry, x equal to 1 line. I want to find the coordinate of this point. So here I want to find, let's say this is origin with coordinate 0, 0, plus let's say this is A with coordinate 2, 0. So here I will take, this is the point. So here this is the point, here I am taking, this is the point P. I want to find the coordinate of this point. Now here x plus y equal to 2, so y equal to x square. So here just put x plus x square equal to 2, therefore x square plus x minus 2 which is equal to 0. So now find the root. So here x square, now multiplication is minus 2 and addition is plus 1. So here minus, here plus 2x minus x minus 2 which is equal to 0 factor. So here I will take x common, so x plus 2, so here I will take minus common, x plus 2 which is equal to 0, therefore x plus 2 equal to 0 or x minus 1 equal to 0, therefore x equal to minus 2 or x equal to 1. So these are the point of here, these are the point, but here x equal to 2 is not belongs to the first quadrant, so here this is not possible. Instead of that, here maybe x equal to minus 2 intersect at this point. So here maybe here if I raise this line, here if I extend this line, here x equal to minus 2 intersect at this point, but I want just this point of intersection. So here I will take x equal to 1. So here if x equal to 1, I want to find the value of y equal to 1 square which is equal to y equal to 1. So the point of intersection at this point is 1, 1. So here I got the point of intersection at origin 0, 0, at point P 1, 1 and at point B 0, 2. Now tell me the region. Where is the region? So now here I am find the point of intersection. Now tell me the x belongs to this closed interval 0 to 1. So here x belongs to this closed interval 0 to 1 means x takes all the value from 0 to 1. So here no need to take this value for x. So here this is not contained in my closed interval 0 to 1. So here exclude this region. Now x takes from only 0 to closed interval 1. So here x takes from, so this is the region. So here for x x equal to 0 along the y-axis and x equal to 1 up to this line x equal to 1. This is my line. So here y-axis to x equal to 1. This is my region along the x. So with respect to x. Now here y equal to x square. So this is the graph of my y equal to x square. This is the graph. Now y equal to x square. This is the graph of y equal to x square. And y takes. So here y is greater than or equal to x square. So here y, here the value of y is greater than or equal to x square. So this is the y equal to x square. So here this is the y equal to x square. Here along this curve y equal to x square. But here y is greater than or equal to x square. Means these are the value of y. Now and which is less than or equal to 2 minus x. So which is less than or equal to this line. So here which is less than or equal to this line. So y takes value which is greater than or equal to x square and less than or equal to this line less than or equal to 2 minus x. So here my region of my integration is this part. So this is the region of my integration. So here O, P and B. So this is the region of my integration. Now here I find the region of my integration is O, P, Q with point of intersection at origin 0, 0, at P 1, 1 and at B 0, 2. So here this is my region of my integration where I want to evaluate, where I want to find the total accumulation of this function over this region. I want to find the total effect of this function xy over this region from here O, P and B. So this is the region. Now here I found, here with the help of this graph, here I find the point of intersection and the region and the point of intersection and region. Now here in the question they are saying, so here so first I will write, so this is the graph here. Now I can say the region of my integration. Here I find the region of my integration. First I will write the correct form of order of integration. Now here inner limit in terms of x variable. So first integrate must be with respect to y and then x. But here in the question they are saying inner limit in terms of x variable, but here they are dx and dy. So this is the wrong order. So here first I will write since inner limit in x variable, so integrate first with respect to y and then x. So therefore the correct order of integration is, so here the correct order of integration is I equal to, so here 0 to 1, here x square to 2 minus x, y, this is dy and this is dx. So this is the correct form of my order of integration with respect to this limit in terms of x variable, that is dy and dx. Now I want to change this order. I want to change the order of my integration with respect to this. So here I want to change from dy by dx to dx and dy. So while changing this order by dy by dx to dx dy, I want to change the limit in terms of y variable. So here how to change is the following. Now so here this is the correct order of my integration 1. Now here in this correct order, so here this is the correct order of my integration. First integrate with respect to dy and then dx. So here you can draw, so here according to this order, first integrate with respect to dy and then dx. So must draw the vertical strip which is parallel to y-axis. So here I will draw one vertical strip. So here I will draw one vertical strip. Let's say this is my vertical strip A. Let's say I will draw one vertical strip. Let's say CD, which is, let's say this is straight vertical strip CD, which is parallel to y-axis. Now here I will draw one vertical strip CD, which is parallel to y-axis. Start from the curve y equal to x square and terminate on the line. So here this is the line where x plus y equal to 2. So the equation of this line is x plus y equal to 2. So here my strip CD start from this curve y equal to x square and terminate on this line x plus y equal to 2. Now I want to cover this region OPQ. So here the base, let's say that this is the base of my this strip CD, which is occur on this curve, and the here head of my this strip CD, which is occur on this line. So x plus y equal to 2. So here now here at this point the value of here I want to here, so this is the height along the y axis. So here y equal to x square. I want to find the value of y at this point. So here at each and every point the value of y along this line is different. So here this is x plus y equal to 2 is the equation of line. So here I will write the y equal to 2 minus x. Here y equal to 2 minus x. So this is the value of y at each and every point. This satisfies this equation of this line. Now so here I will write the first step. So this is second step. Here draw. So say about the region. So here the region of my integration is the region of integration. The region of integration is, so here the region of integration is OP and OPB with point of intersection at O 0, 0, at P 1, 1, and at B 0, 2. So this is the point of intersection, and my region of integration is OPB. So OPB is the region of integration with point of intersection at origin 0, 0, at P 1, 1, and at B 0, 2. So here now to cover the region, draw a vertical strip. So here I am integrating first with respect to dy and then dx. So to cover the region, that is region is OPB. To cover the region, draw a vertical strip. Let's say CD, which is parallel to y-axis. Here, according to this, draw a vertical strip CD which is parallel to y-axis. Start from curve y equal to x square, and my strip start from this curve y equal to x square and terminate on this line. Start from the curve y equal to x square and terminate on line x plus y equal to 2. So here my strip CD start from this curve y equal to x square and terminate on this line x plus y equal to 2. So therefore I want to write the limits of x and limits of y with respect to this order, so which is given in the question, but again I will write. Therefore limit of x and limit of y. So here limits of x. So here limits of x start from here 0 to 1. So here my strip move from at this point here OB to this point to cover the whole region. So here along the x-axis my strip move from here to here. So along the x-axis my strip move from this point to this point. So here at this point the value of x is 0, and at this point value of x is 1. So here x equal to 0 to x equal to 1. So this is the limit of x, and limits of y. Here height along the y-axis. So here height along the y-axis, the height of my strip depend on this curve and this line. So here at this point the height of my strip is different. At this point height of my strip is different. At this point height of my strip is different. In this way my height of my strip is changing with respect to this curve and this line x plus y equal to 2. So here limits of y. So here limits of y start from y equal to x square to here y equal to x. The value of y for this line y equal to 2 minus x. If x plus y equal to 2, y equal to 2 minus x. Therefore y equal to x square to y equal to 2 minus x. These are the limits of x and y with respect to this order here, which is given in the question, which is wrongly. After that here I am writing the correct order. So with respect to this correct order dy dx, so these are the limit. Now I want to change this order from dy by dx to dx dy. while changing this order, I need to change this limit also. So here I want to cover this whole region with the help of horizontal strip which is parallel to x-axis. How to cover is the following. Now here I will draw the same graph. Here instead of this vertical strip, here I want to cover the same region OPB with the help of horizontal strip. Now here just observe one thing. So here I need this place to draw the graph. So here this is the parabola. Let's say here, let's say y equal to x square. The graph of y equal to x square. Now here y equal to x square, and here I will draw this line which intersect here at here. Let's say this is the P, here 1 comma 1. Let's say this is the origin at 0 comma 0, and here this is the point. Let's say B with point of intersection 0 comma 2, and so here this is the line. So here this is my line x plus y equal to 2. Now so here I want to cover this region OPB. So here I want to cover this region OPB. Now here I want to, here in the given question, first integrate with respect to dy and then dx. If you are integrating first with respect to dy, use the vertical strip which is parallel to y-axis. But now they are saying change the order with respect to this correct order. Change the order of integration with respect to this correct order. So here now I want to change this from dy dx to dx and dy. So here I want to cover the same region with the help of horizontal strip. Now here just observe one thing. While covering this region, the one terminal of my strip is fixed along this curve y equal to x square, and the other terminal of this strip is fixed along this line x plus y equal to 2. So here this here D terminal, so of my strip CD, this D terminal is fixed from this point to this point, which is not jump here, which is fixed on this same line x plus y equal to 2, and this C terminal of my strip CD, which is fixed along this curve y equal to x square. But now I want to use I want to cover the same region with the help of horizontal strip. Let's say if I draw the strip, let's say this is the one strip here. Let's say this is the one strip C and D. So let's say this is C and D. Now I want to cover this whole region. So here the C terminal of my strip CD, which is occur on the y-axis. Let's say this is my y-axis. So here let's say this is my y-axis. The C terminal of my strip CD occur on the fixed y-axis. So here this is not here, but here the D terminal of my strip while covering this region OPB. So while covering this region OPB, so while covering this whole region, the D terminal of my strip. So here in the starting I will put this strip here, put this strip here, put this strip here, put this strip here, put this strip here. After this point P, the D terminal of my strip move to this point. So here C terminal of my strip is on the fixed line. So is on the fixed line y x equal to 0, that is y-axis. But here D terminal of my strip change the line. Here change the position from x plus y equal to 2 line to the curve y equal to x square. So that's why I want to divide this whole region into two parts. So here I want to divide this whole region into two parts. So let's say this is my part 1. Let's say this is my part 2. So here I want to divide this whole region into two parts. So here I am drawing. Here I am dividing this region OPB into two parts. Let's say here I will take this point of intersection OPB, and let's say this is R. Now here in the second region also, here I want to cover. Here I want to cover this region. So here with the help of one strip, let's say this is C dash and D dash. Now just observe one thing. So here let's say this is my one part, one region with PBR. With PBR, here I draw the one strip CD which is parallel to x-axis. And in my second region, let's say OPR. In this second region OPR, here I draw the strip C dash D dash which is parallel to x-axis. Now in the both region, here in this first region, my strip CD start on y-axis, that is start on y-axis and terminate on this line x plus y equal to 2. But in my second region, my strip C dash D dash start on y-axis and terminate on this curve. So here this strip terminate on line and this strip terminate on the curve. So here at this point the value of x is different. So here I want to find. So here previously I am finding the value of y in terms of x. Now I want to find the value of x in terms of y. So here 2 minus y, and I want to here I am finding the value of y in terms of x square. Now I need value of y x in terms of y. So here if y equal to x square, if y equal to x square, then x equal to plus minus under root y. But we are in the first quadrant of xy plane, so here in place of that, here I am only taking x equal to root y. So here at this point, at each and every point from here to here, I am considering x equal to root y. So here y equal to x square, this curve, and x equal to root y, because we are in the first quadrant of xy plane. Now just tell me, here I want to cover the same region with the help of this two strip. One in first region CD and one is other strip C dash D dash in my second region. Now tell me, so here first I will write some theory part here. Here to change the order of integration, to change the order of integration So here I am saying to change the order of integration. Now tell me, the correct form is dy dx. This indicates that first integrate with respect to y and then dx. Here I am saying with respect to this correct order to change the order of integration. That is, so here that is to integrate first with respect to x. Here first integrate with respect to y and then x. After changing order, first integrate with respect to x and then y. That is here I am writing in bracket. That is here dx and dy. So here I want to change from dy dx to dx dy. So here don't write. So this is not mandatory. So this is not. This is no need to write. Here I am saying in the wording to change the order of integration. That is to change. That is to integrate first with respect to x and then y. So this is the same. So here integration first dx dy. So here first integrate with respect to x and then y. So this is. So here no need to write. Here to change the order of integration, that is to integrate first with respect to x and then y. Here divide the region R equal to, here I am divide the region R, let's say equal to OPB into two sub-region, say R1 equal to, so here I will take this is R1 and I will take this is R2. R1 equal to PBR. So here PBR and R2 equal to, so here R2 equal to, here this is OPR. So R2 equal to OP and this is R. So here I am dividing my complete region OPB into two sub-regions. So here R1, which is PBR, and my R2 is OPB. So here this is the two sub-region. Here I am dividing my original region into two sub-region. Now here I want to write some theory part. So I draw the vertical strip in my region R1 CD, which is parallel to x-axis, and draw the vertical strip C dash D dash in my region R2, which is parallel to x-axis in sub-region 2. So here I will write the same theory. So here draw a vertical strip CD, which is parallel to y-axis in sub-region, which is parallel to x-axis. Here draw a vertical strip CD. Here draw the vertical strip CD, which is parallel to x-axis in sub-region. Here in sub-region R1. Start from here. My strip CD start from y-axis. So here start from y-axis and terminate on the line. So here I will write here and terminate on the line x plus y equal to 2. So here I will write here, please I don't have space here. So here my strip CD start on the y-axis and terminate on terminate on line x plus y, which is equal to 2. In the same way, here and in region R2 draw a horizontal strip. Sorry, this is horizontal. So here I am saying vertical. This is horizontal. Here draw a horizontal strip C dash D dash, which is parallel to x axis. Here start from y axis and terminate on curve y equal to x square. Here my strip start on y axis and terminate on this curve y equal to x square. Now here write the limits of x and limits of y in terms of in region 1 and in region 2. So therefore here I will write limits of x in region R1. So here limits of x in region R1, therefore x equal to, now tell me limits of x in region R1. So here limits of x in region R1, x equal to, here my strip CD start from y axis and terminate on this line. So here on y axis x equal to 0 and at this point x equal to 2 minus 1. So here limits of x in R1, so here limits of x equal to 0 to x equal to 2 minus y. So here x equal to 0 to x equal to 2 minus y, and limits of y in region R1, which is equal to, so here y equal to at this point. Now here we have to know the point of intersection at this point. So here from here to here 2, so here I will take this is 1 comma 1. So here the point of intersection. So here point of intersection at P is 1 comma 1. So here point of intersection at this point is x is 0 and y is 1. So here y equal to, so here my strip move from this point to this point. So here allowed from this point to this point. So along the height along the y axis is y equal to 1 to y equal to 2. So here y equal to, so here y equal to 1 to y equal to 2. So in my sub region, limits of x and y in my sub region R1. So this is R1. So here this is my region R1 and this is my region R2. Now here in the same way I want to write the limits of x and y in region R2. Limit of x in region R2. Here in region R2 and limits of x. So here limits of y in region R2. So here I want to write the limits of x and y in region R2. So here first of all limits of x. So here my strip C dash D dash start from y axis and terminate on this curve y equal to x square. The value of x is root y. So here x equal to 0 to x equal to root y. X equal to 0 to x equal to root y and height along the y axis. So here y equal to 0 to 1. So here limits of y equal to, here y equal to 0 to y equal to 1. So here height along the y axis y equal to 0 to 1 and height along the x axis x equal to 0 to x equal to root y. So these are the limits of x and y in region R2. These are the limits of x and y in region R1. Now in the starting here I am converting my region R into two subregions. Therefore after changing the order of integration, so here therefore after changing the order of integration, after changing, so here after changing order of integration, is, now here after changing the order of integration, first I will write this here correct form. So here correct form 0 to 1, here x square to 2 minus x, this is xy, here correct form is dy dx. Here after changing this, here
divide into two subregion. So here first this subregion R1, here in the subregion R1 limits of tell me the limits of x and limits of y. After that in the subregion R2 tell me the limits of x and limits of y. So here in subregion R1 limits of x. So here I want to change from here this is x y and this is x y. Here I want to change from dy dx to dx dy. So here this is dx and then dy. So this is dx and then dy. Now here if you are integrating first with respect to x in subregion 1, write the limits of x. So here limits of x equal to, so here x equal to 0 to 2 minus y, and limits of y. So here limits of y equal to 1 to 2. Now in subregion 2, so here integrate first with respect to x and then we dy. If you are integrating first with respect to x, write the limits of x. So here in subregion R2 limits of x equal to 0 to root y, and in subregion 2 limits of y equal to 0 to 1. So this is the order. So here my region R, here in the shortcut region R is divided into here R1 plus here R2. So here this is R which is equal to, here after changing this order, so here this is original order dy dx. My region R is converted into two parts, R1 with this limit dx dy and R2 with this limit and dx dy. Now here I want to integrate this with respect to first x, and I want to integrate this with respect to first x and then y. So here how to integrate is the following. Now integrate first with respect to x and then y. So here if you are integrating first with respect to x, treat y as a constant. So here which is equal to here 1 to 2. So here I will take y here. Here integration of x with respect to x, this is x square by 2, and limits of here, these are the limits 0 to 2 minus y. So here after that here this is my dy plus here integration from 0 to 1. Here I will take this is y, integration of this x with respect to x, this is x square by 2, limits are 0 to root y. At last integrate with respect to dy. So here which is equal to here 1 to 2, this is y. Now here y as it is. Now here put upper limit minus lower limit. So here this is equal to 2 minus y whole square by 2 minus, so here 0 by 2. So here this is 0, this is dy plus, now here 0 to 1. So here 0 to 1. So this is y. Now here root y. So root y whole square by 2. Upper limit minus lower limit is 0. No need to write. This is simply dy. Now here I want to just simplify. So I hope all of you understand this curve. So here now I don't have space. I will use this space to write, to evaluate this integral. So here now here just expand this back here, which is equal to, so here which is equal to, so here I will take this 1 by 2 common. So here outside constant. So here limits are 1 to 2. So here this is y, and here a minus b whole square. So here 4 minus a square minus 2ab. So that is 4y and plus b square y square. This is dy plus here in the same way I will take this 1 by 2 constant outside. Here 0 to here 0 to 1. So here this is 0 to 1. Here square and square root get cancelled. This is y square by 2. So here this is simply y square and dy. Now here I will multiply this y square to throw out this bracket, which is equal to 1 by 2 times here 1 to 2. So here this is 4y minus here 4y square plus y cube. This is with respect to dy plus 1 by 2 times. So here this is with respect to here 0 to 1 y square and dy. So here which is equal to here 1 by 2 times. So here integration of 4y with respect to y. So here here I will write here 4y square by 2 minus, so here 4y cube by 3 plus y to the power 4 by 4, and limits are 1 to 2, plus 1 by 2 times here y 1 by 2 times y square, limits of y square is y cube by 3, here limits are 0 to 1. So here this is limits are 1 to 2, this is 0 to 1 here, which is equal to, so here 1 by 2 times, so here 1 by 2 times, so here this is 2 times, here upper limit minus lower limit, so here 2 gets cancelled, so here 2 4, so here 2 times y square, here again I will write 2y square minus 4 by 3 y cube plus y square, so here no need to write again, so just directly put the limit, so which is equal to, so here 1 by 2 times, so here 2 square, so here 2 square minus 4 by 3 times 2 cube minus, so 1 by, here this is 2 to the power 4 by 4. Now this is upper limit, here this is upper limit minus lower limit, here 1, so lower limit is, so here lower limit is, here this is 2 times 1 square minus 4 by 3 times 1 cube plus here 1 to the power 4 divided by 4. So here this is upper limit minus lower limit plus 1 by 2 times. So this is here 1 by 3 minus 0. So here therefore which is equal to here 1 by 2 times. So here big bracket, here 2 into 2 to the power 2. So here 2 square. So here 4 into 2 8 minus. So here 4 by 3. This is 8. So here 8 into 4. So here I will write directly 32 by 3 plus, so here 2 to the power 4, 16 by 4, that is simply 4. Here this is first bracket minus. So here with this minus, here I will multiply this here. This is minus 2. So here 2 into 1 square 2. So here minus 2 plus this is 4 by 3, 1 cube 1 minus 1 by 4. So here this is complete bracket and plus, so here this is 1 by 2, 1 by 3, this is simply 1 by 6. So here I want to multiply this 1 by 2 to throughout this bracket, which is equal to 1 by 2 times. So here 8, here 4 minus 2, 2. So here 2 plus 8, this is simple 10 minus 32 by 3 plus 4 by 3 minus 1 by 4 here plus 1 by 6, which is equal to, so here multiply 1 by 2. So here this is 5 minus, so here this is 16 by 3 plus 2 by 3, here multiplying, and this is here minus 1 by 8. So here plus 1 by 6. Now here simplified, which is equal to here 15 minus 16 divided by 3 minus 1 by 3 plus 2 by 3, here minus 1 by 8 plus 1 by 6. So start here. This is minus 3 plus 6. Here minus 1 by 3, 2 by 3, which is equal to 1 by 3 minus 1 by 8 plus 1 by 6, which is equal to, so here 8 minus 5 divided by 24. So here 8 minus 3 5. So here 8 minus 3 is 5 divided by 24. Here this pair plus 1 by 6. So here I want to make denominator 24. So here multiply and divide by 4. 4 and this is 4, which is equal to 5 by 24 plus 4 by 24, which is equal to 9 by 24. Here 3 3s are 9, 3 8 are 8. So here 3 into 8 24. So here this is the answer, 3 by 8. So here in the first question given, so this is the final answer. First, this is the given first limit 0 to 1, second limit x squared 2 minus x, but here that must be the dy, but here in the question which is given as dx dy. So here first write the correct order, that is dy dx. After writing the dy dx, according to that correct order, change the order of integration. So while changing the order of integration, so from dy dx to dx dy, here I am dividing my original region into two parts. So here this is
limits of x and y with respect to my first region, and this is the limits of x and y with respect to the second region R2. So here after changing the order, that is this. So here after changing the correct order, 0 to 1, x square to 2 minus x, x y dy dx. So here from dy dx to dx dy. This is integration of the region over region R1, and this is region R2. So here integrate first with respect to x and then y. While integrating first with respect to x strict y as a constant. Here I am taking y outside this first integral. So here x square by 2. So after calculating this, you will get this answer 3 by 8. So this is the way to solve this question. So you can solve. Thank you.